In this video, we will go through the input processing steps for making a simple buried design. We will be starting from an existing workspace. When you have just opened up a new instance of Quantum GIS, you can press the Switch to Area View button. This will automatically open up the correct QGIS project view. Now, the first step will be to create a network of possible trenches. To do this automatically, we can use the Create Trenches button. This feature reads in the data of the street center lines. It then creates a double network, where possible trenches have been added on both sides of each street. If we take a closer look at the area, we can indeed see that it now contains the street side trenching locations. The output of this step is located in the In Possible Trenches file. Each input processing step will generate its separate file, located in the Intermediary Files group. It is possible to manually adjust the output of these files. This can be useful to improve the practicality of the automatically generated output. So, as a recap, what we have now is our trenching skeleton, where potential trenches have been added on both sides of each street. The next step will be to create the drop trenches. This feature will try to connect each demand point onto the nearest possible street side trench that we just created. Such a connection is what we call a drop trench. This feature has two options. The first one will create a separate drop trench for each building. There's also an option to create shared drop trenches. The second option will try to interconnect two neighboring demand points onto a single shared drop point location. And indeed, in this case, we can see that each time two buildings have been grouped together. Unless, of course, we have a demand point which is isolated, then that one will still receive its own separate drop location. Again, the output of this input processing step is located in a separate output file. This time, it is called the In Drop Trenches file. Now, with this step being finished, we are almost done with doing the basic input processing. There's one more step that we have to do, which is to create the possible crossing locations. This feature reads in the location of the customer drop points that we just created, and it will attempt to connect each of these points to the opposite side of the street. It's very important to note that these connections are just possible crossing locations. This means they are candidate locations, where a cable can cross the street to an opposite side. But it doesn't mean that all of these crossings will be taken in the actual design. Instead, the software will try to optimize their usage based on your specification in the rules. The output of this processing step is once more placed in its own file, called In Crossings. As mentioned earlier, all of these intermediary files can be manually adjusted by the end user. For example, you might want to prevent crossings on some specific roads in your area. This could be because you know that acquiring a construction permit would be too expensive. In order to remove some crossings, first select the layer. Make sure that it is editable. Then you can just make a selection of all the crossings that you want to remove and simply delete these features. So it's very easy to make any manual modifications to the automatically generated output. The same principle holds for the other output files that are located in the Intermediary Files group. For instance, you might want to change some of the automated drop trenches. Maybe a field survey has shown that a certain drop is impractical. Let's change the shared drop point to single drop trenches. Again, select the appropriate layer and toggle its editing mode. Then, using the Node tool, we can simply move the individual trenches to our liking. Now we have manually changed the automatic output of the pre-processing steps. Once we are done with making any manual fine-tunings to our input files, it's very important to actually save those changes. The way FiberPlanet does this is by processing the area. In this step, the automatically generated and manually updated intermediary files are examined, and they are combined into a single output file, which is referred to as the mapping file. The processed edges layer is a visualization of this mapping. You can consider this file as a mapping of all your input data into a single unified format. This mapping will be used for any subsequent calculations. So it's very important that when you make any changes to the input data of your design, that you finalize these changes by processing your area in order to update the mapping file as well. This concludes the processing steps for a regular buried area. There are a couple of advanced features that can be used to customize the output even further. For example, let's go back to the Street Center Line doubler under the Create Trenches button. Select the Street Center Lines layer and open its attribute table. You will notice an attribute that has the name width. If you're using your own input files, this attribute might not yet be present on the data. In this case, you can create it by opening the field calculator. In this dialog, enter the name of the attribute field that we are creating, which is width. Note that it is important to use the correct capitalization in order for the software to detect the attribute. Select the type of data that this field will contain. In this case, it is an integer number. In my files, I already have the attribute available, so I won't be creating a new attribute column. Now, what can we do with this width attribute? It is used to specify the width of a specific double street, expressed in meters. This can be useful if we have a main road somewhere, for which we want to indicate that it's slightly wider than the other roads in our area. To change the default width, select the road. Open up the attribute table. Bring your selection to the top of the table, and then just change the width to the preferred value. Note that by default, a width of 8 meters is used. Let's change the width for the street to 12 meters. Remember to save the changes. Now, let's see what happens if we rerun the Create Trenches step. Remember to first re-enable the intermediary files, because right now we only see the mapping. We notice that the intermediary file has changed compared to the data in our mapping file. The street now has a width of 12 meters, whereas in the previous result, it used the default width of 8. We can see that the drop trenches aren't connecting to the street anymore. We will have to rerun the Create Drop Trenches step again. This ensures that the drops are now placed correctly onto the slightly wider street. We also want to recreate our crossings for this step. Note that any of your manual modifications will be overwritten when you rerun an input step. Now we have our street, which is slightly larger than the rest of the area. Another attribute which is fairly interesting is the subtype. This attribute can be used to create some sort of classification for your streets. This classification can be used to associate different trenching costs to different street types. For instance, certain streets might be more expensive to trench. A typical example would be the difference between a paved road, a road with asphalt, or a dirt road. So we can indicate this by, again, selecting the street, opening the attribute table, and bringing the selection to the top. Remember to toggle editing. Then enter the preferred value for the subtype attribute. This can be any textual description of the road type. In this case, let's just keep it simple and just call it expensive trench. We can have multiple different subtypes in one design. For example, let's select some other streets over here. This time we want to make them cheaper, so we indicate that they have the cheap trench subtype. Be sure to update all of the selected entries. Save the changes. If we now recreate the possible trenches, they will also have their own subtype. Each possible street side trench that was created based on a street center line with a subtype will also have that same subtype. In this case, we see that these trenches are indicated as being cheap. Here we see an edge that was created from one of the default streets. It doesn't have a subtype. And finally, the other one, which is located over here, does have the expensive trench subtype. Now that we have added a subtype to our trenches, we can use these to associate different trenching costs in the rules and material file. This will be the topic of a following video. This concludes the tutorial of doing input processing for an underground area.